All right, we're going to be talking about chemical reactions and balancing chemical equations. So as you remember from yesterday, we have the reactants, that is what we start with, and then the arrow, remember, means yields or produces, and that is our products. So we have two different types of atoms here, some green ones and some yellow ones, and then they produce these right here, these double atomed compounds. So remember when we're writing our chemical equations, there's a before and after. The reactants are the before, okay, and the products are the after. So this is what we started with, magnesium and oxygen, or magnesium oxide, if you remember how to name, plus carbon. And this is going to give us carbon oxide, carbon monoxide, if you will, and magnesium. So magnesium oxide form carbon monoxide. So magnesium oxide right there reacts with, that's what the plus sign means, carbon to form carbon monoxide plus and magnesium. So we're not going to do that part. So when we read our chemical equations, you should look at the coefficient. Remember, the coefficient tells you how many of these molecules there are. So 4 molecules of NH3 react with 5 molecules of O2 to produce 4 molecules of NO and 6 molecules of H2O, which, as you remember, is water. We're going to skip that part. Okay, so now we balance. So balanced chemical equations. This can be either really hard or really easy, depending on how you make it. So basically the goal is to get the same number of each type of atom on each side of the equation. So this is the left side of the equation, this is the right side of the equation. And the sides are dictated by where the arrow is. So this is the arrow, so everything to the left of the arrow is the left side of the equation, everything to the right of the arrow is the right side. So our reactants and our products, if we look, we can count how many atoms are right here. There's one atom, okay, one atom of aluminum. There's one atom of sulfur. If we look at the right side, okay, here we have 2 atoms of aluminum and 3 atoms of sulfur. Is that balanced? No, because we don't have the same number of aluminum on this side as this side, or the same number of sulfur as this side on this side. Now we can balance it by adding coefficients, not by changing the subscripts, which we'll talk about in a sec. But notice how the subscripts don't change on any of these, because that changes the identity of the compound. Instead, what we do is we add coefficients. So we knew we had 2 aluminums on this side, so we add a 2 for a coefficient here. So now we have 2 aluminums, plus we knew we needed 3 atoms of sulfur here, so we add a coefficient here of 3. So now we have 2 aluminums plus 3 molecules of sulfur, and that's going to give you 1 molecule of Al2S3. And that's balanced because there are 2 aluminums here, 2 aluminums here, 3 sulfurs here, 3 sulfurs here. The reason why this is important is because it shows that matter is conserved. Whatever you put into it, you have to get out of it. So here we have 2 molecules of H2, or excuse me, a single molecule of H2 and a single molecule of Cl2. Here we have 2 molecules of HCl. So you see 1, 2 H's, 1, 2 H's, 2, 1, 2 Cl's, 1, 2 Cl's. So even though they are in a different form, okay, they still exist. Whatever we have put in here, we get out. It's just in a different form. Remember, matter cannot be created or destroyed. It can only change form. Okay, so in any ordinary chemical reaction, matter is not created or destroyed, and we know that. So we balance with coefficients. So coefficients in front of the formula balance each type of atom. So when we add these coefficients, the reason why they exist in so many chemical equations is because they're usually already balanced. And if they're not already balanced, it's our job to balance them. So the way we do that is we count how many there are on each side. So we'll start with this side with the first atom. So a coefficient isn't an atom, so we skip the number here and we go to the first atom. So the first atom is nitrogen. So we say, oh, there are 4 nitrogen, because nitrogen doesn't have a subscript, remember? So 4 nitrogens. Then we say, oh, what's on the other side? And we say, oh, look, 4 nitrogens. Same. Now we say hydrogens. Okay, so this is H3. There's 4 molecules of that H3, so 4 times 3 is 12 hydrogens. Okay, so there are 12 hydrogens there. On this side, we have hydrogen here. There's 2 hydrogens in this molecule, and there's 6 of those molecules, so 6 times 2 is 12. So that's the same. Now there are 10 oxygens, so this molecule, O2, has 2 oxygens, and we have 5 of those molecules, so 5 times 2 is 10. On this side, we have 4 molecules of oxygen in this compound, and in this one we have 1 times 6, so 6 molecules of oxygen in this compound. 6 plus 4 equals 10, so we have 10 total oxygens on this side. And so that is a balanced formula because what's in on this side comes out on this side, the exact same. Now, steps when we balance a chemical equation. Hold on one second. Okay, so the steps to balancing a chemical equation is going to be first you're going to write the chemical equation for the reaction using formulas and symbols. I'm not going to make you guys do this part. I'm going to make sure that I have the chemical formula already written there for you. You just need to make sure you know where the reactants are on the left side and where the products are on the right side. Remember, anything to the left of the arrow, the reactants, anything to the right of the arrow are the products. Step 2 is you're going to write down the symbol of each atom beneath the equation. So here, the very first thing I'm going to do is I'm going to say, okay, the first atom I see is carbon. I'm going to write carbon down here. Then I see hydrogen. I'm going to write hydrogen down here. Then I see chlorine. I'm going to write chlorine down here. That's the very first step. You'll notice that the atoms on either side of the equation are going to be the same. And if they're not, there's a problem. You're missing something. So when you write down the atoms on this side and when you write down the type of atoms on this side, they should be the same. We're not to this part yet, so ignore this. Step 3 is we're going to count the atoms of the reactants and the products and write them down next to their symbol. So now that we have got C, H, and Cl already written down, we are going to say, okay, how many carbons are there? There's no subscript, there's no coefficient, so therefore there is only 1 carbon. Okay, now we're going to count the hydrogens. There's no coefficient, but there is a subscript, so that means there are 4 hydrogens. I'm going to write 4 hydrogens. Okay, here, this 4 is going to be added later. So in the original equation, ignore this 4. So originally it was just Cl2. Okay, so when we started, there was only 2 chlorines, so we wrote a 2 here. Now we're going to check and see the other side. There's no coefficient, no subscript, so there's 1 carbon. Hydrogen. Remember, these green ones are added later, so ignore them. So that means there is only 1 hydrogen. That's already a problem, right? Because we have 4 on this side, so we need to have 4 on this side. And here, once again, ignoring the coefficient, there's no subscript, so there's 1 chlorine. That is also a problem because, or excuse me, there's 4 here and 1 here, so there's 5 total chlorine. So that's a problem because you know you have 5 here and you have 2 here. Okay, that's a problem. So now we need to figure out with our coefficients, how do we fix that? Okay, so we're going to choose coefficients that balance the equation, starting with the first atom in the reactants and working to the right. Generally, now this is just a hint, generally when there is an even number of an element on one side and an odd number on the other side, you're going to place a 2 or a multiple of 2 in front of the compound containing the odd number of atoms. So what we are first probably going to do is we're going to say, okay, I know that there are 4 hydrogens on this side, or 1 hydrogen on this side and only 1 on this side. So I'm going to go ahead and write a 4 here. So I'm going to write a 4 here because that way I have 4 hydrogens on this side and 4 hydrogens on this side. That also changes. That means I now have 4 more chlorines. So I have 4 chlorines here, 4 chlorines here. Now I have 8 chlorines. On this side, though, I still only have 2. So how do I get 2 to be 4? Excuse me, 2 to be 8? Well, I multiply 2 by 4. That makes 8. So I put a 4 in front of the chlorine, And now I check. 1 carbon, 1 carbon. 4 hydrogens, now 4 hydrogens. 8 chlorines, 4 plus 4 is 8 chlorines. That is a balanced equation. So we're going to practice. Okay, the very first thing, remember, is we'd take these and we'd write them all down. Remember, an atom is dictated by a capital letter. If there is a small letter following it, that's a part of that same atom. So Fe, because there's a capital F and a lowercase e, that is one atom. So I'll write Fe right here, then I'd write O, because that's the next atom, and then I'd write H. Now I go to this side, Fe, H, and O. So they're the same. Great. Step 1, good. Okay. Now we're going to look and we're going to count them. So I have no coefficient here, but I have 3 of a subscript. That means there are 3 irons or Fe's on this side, but there's only 1 on this side. So we already know this is not balanced. I have a subscript of 4 on the oxygen, so there are 4 oxygens on this side, and there are one oxygen on this side. Here I have a hydrogen. There's 2 oxygens on this side, and there are 2 oxygens on this, hydrogens. 2 hydrogens on this side and 2 hydrogens on this side. So that part's balanced, but the rest of it isn't. So the very first thing we probably need to do is go to the very first atom. So there's 3 on this side. It'd be very easy to just go to this side and add a coefficient of 3 in front of the iron. So now we have 3. If I put a 3 there, we have 3, okay, Fe3. Okay, that's good. Now we have 3 and 3. We have 2 hydrogens and 2 hydrogens. That's good. But we have 4 oxygens and only 1 oxygen. So that means we're going to need to probably put a 4 in front of that. That unbalances our hydrogens though, right? Because now we have 4 times 2, that's 8 hydrogens. And on this side we only have 2 hydrogens. So what do we need to do in order to fix this side now? We need to add another 4. So now if we count them out, we've got 3 Fe, 3 Fe, 4 oxygen, 4 oxygen, 8 hydrogen, 8 hydrogen. So yeah, that's kind of how that works. Okay, I am going to ask you to check yourself really quick. And we're going to have you do balance these equations. So I want you to balance that one right there. So pause your video and go ahead and balance that. Okay, if you wrote down that M, G, and N were the only molecules or only atoms on each side, that's good. If you figured out that you started with 1 Mg and 2 Ns on this side, and you started with 3 Mg and 2 Ns on this side, that's also good. If you figured out that you needed to multiply the Mg here by 3 to make the Mg the same, that's great. So you put a 3 here. Now you need to figure out, is it balanced? 3 Mg, 3 Mg, 2N, 2N. That is balanced, okay? Let's try this one. If you wrote, go ahead and pause it and do it. Okay, if you wrote there is aluminum and chlorine on this side, Al and Cl on this side, and Al and Cl on this side, that's good. Now you counted them. If you started with 1 aluminum and 2 chlorines, that's good. And 1 and 3 on this side, that's good. But that also means it's not balanced. So we'll start with saying, okay, look, this is an even number, this is an odd number. So if we go ahead and put a 2 here, like our hint in our directions told us, if we put a 2 here, now we have 2 aluminum and 6 chlorines. So now we have 2 aluminums, so we need to put a 2 in front of aluminum. So now we have 2 aluminums, but we still only have 2 chlorines, and we need 6 chlorines. So we need to also put a 3 in front of the chlorines. So that's all the practice we're going to do now. You'll do a lot of practice on Monday. Yeah, so I hope this makes sense. I know it's a little confusing. Once you start, it won't be nearly as confusing. So good luck. Thanks for watching.